Hello students, in previous video we saw motional EMF, what is motional EMF and um, what is the significance or expression for motional EMF. We saw that motional EMF can be given as epsilon is equal to BVL, and in this video we'll discuss one more way of expressing the phenomena of electromagnetic induction or basic reason behind induction of EMF. And along with that, we will also discuss if law of conservation of energy is obeyed in the phenomena of electromagnetic induction. So, in the topic of electromagnetic induction or in motional EMF, we saw that if we have a U-shaped wire with a movable rod placed on it, if it is subjected to external magnetic field, we say that there is flux linked with this part, and how much is the flux? We said that flux can be given as phi is equal to BA cos theta is 1, and this is L, this is X, and if we move this rod with velocity V, and if we bring it somewhere here, how far? Let the distance be delta x. Then we say that there is change in flux, and because of that there should be induction, and that induced EMF should be BVL. Okay. Now I am drawing the same figure but from different perspective. So now I consider that the loop is like this. Now this is L. Okay, and the conducting rod, let me place it here. So this is the rod, and here is L, this is X, and when we move the rod with velocity V, and when we bring it here, where is our delta x now? This is the delta x. Okay, now where is magnetic field? So this is top view. So if you are viewing this figure from here, we can say that magnetic field lines are going inside this screen. Both are same figure but different perspectives. Now why do we need this? The reason is as explained earlier, when you move this rod with velocity v, there is change in flux, and because of change in flux there is induced EMF. And what is the nature of induced EMF? Should it be like this, current induced should be like this, or it should be in opposite way? So option 1 or option 2? Let me make it more clear. If it is A, B, C, D, so in this figure A, B, C, D, let me remove this to avoid unnecessary confusion, removing all the field lines. Okay, so my question is, what is the nature of induced EMF? Should it be from A to B to C to D to A, or the induced EMF would be from A to D to C to B to A? Now, as you move this rod CD by delta x distance, you are increasing flux, and the effect is very similar to the north pole approaching the coil. So this situation is very similar to this one, where north pole is approaching this coil. Okay, and coil will feel as if flux is increasing. And what will happen in this case? Applying Lenz's law, we can say that the induced EMF will be in such a way that north pole of the coil should be facing the external north pole. And applying similar logic, so we can say that the induced current in this loop would be in such a way that induced north pole should be in upward direction. And to have that, the current must be going from A, B, C, D, A, and not in this manner. Okay, this is possible if we are taking rod leftward. Then you will be having current, induced current from A to D to C to B to A. Okay, but for now, this is the direction of induced current. Now there is one more concept involved here. As there is induced EMF, there will be some current passing through rod CD, isn't it? And if there is current passing through rod CD, then there should be force experienced by the rod. Why there should be force experienced by the rod? Because we know that F is equal to I L cross B, isn't it? So if I consider the L to be in Y direction, now see, the current is going from C to D. Okay, so I consider I L J cap cross. What is the direction of magnetic field? Let it be negative Z direction, so minus B K cap, and then I have I L B. What is J cross K? It is minus I cap, so ILB minus I cap. Now what is happening here? See, we are talking about force F, which is minus ILB I cap. What do you mean by minus I cap? So we are talking about a force which is acting on this rod in this direction. Who is that force? Why there should be force? So this is the Lenz's force. This force is called Lenz's force. And what it is doing, it is making sure that law of conservation of energy is obeyed. So when you try to move this rod with velocity v, you will have to apply external force equal to ILB. Okay, so it means that you will have to put in your effort, you will have to invest your energy, and your energy, your mechanical energy, is converted into electrical energy. So how much is the mechanical energy? So mechanical power, PM if I call it, it is force into velocity. Okay, and how much is the force? Force is ILB into V. And how much is the electrical energy or electrical power? So electrical power, if I call it PE, it is voltage into current, or else induced EMF into current. How much is induced EMF? It is BBL. Now look at this too. So I can say that mechanical power is equal to electrical power, and hence law of conservation of energy is obeyed in the phenomena of electromagnetic induction. Okay, so that was the topic, that whenever you try to move the rod, even though the U-shaped wire is frictionless, you will have to put in your energy to move this rod. And why we are using our energy? We are using our energy against this force, Lenz's force. Okay, and you can check by yourself. If you try to move rod in this way inside, then you will see that the Lenz's force will be in plus I cap, in positive x direction. So the nature of lens force is always to oppose the external force or the change. Now, one more thing I would like to add here is that if I take Ohm's law, V is equal to IR, instead of V I am taking epsilon is equal to IR. We know that I is delta Q by delta T. Okay, and according to Faraday's law, uh, this is delta phi by delta T. I am not considering negative sign because I am talking only about magnitude. So what we have, delta phi by, sorry, delta phi by R is equal to delta Q. It means that whenever you consider induction process, there is voltage produced, there is current produced, and there is charge produced. How much is the charge? You can find out with this formula. The interesting part here is that when you substitute all the values of delta phi, it is BA cos theta, you realize that there is no delta T in this formula. It means that the amount of charge produced during the phenomena of electromagnetic induction has nothing to do with time. How fast you are moving magnet, how fast you are moving the rod, time is not important. How much charge is produced is independent of time. Okay, and you can find out with this formula. So that is all for now. Thank you.